Good day. Today I'm entering the digital world of FPV with a FatShark Shark Byte digital FPV system. I'll be using the SharkByte video receiver module, or VRX of course, along with the FatShark TX5S.1 digital video transmitter, which is a single board VTX, and I'll be using the Foxeer Digisight Nano Digital and analog FPV camera. I'll show you how I've connected the camera and VTX with a flight controller on my 4-inch Kobara Micro FPV drone. Then I'll go over the setup of the SharkByte VRX, VTX, and camera using only the transmitter sticks. I'll finish it up with a short beach flight and let you know my thoughts on how the FatShark Shark Byte digital FPV system stacks up against my analog setup of Skyzone 030 OLED screen goggles with the Immersion RC rapid-fire receiver module, arguably the best on the market today. If that sounds good to you, then hit that thumbs up button below and subscribe to your tmacfpv channel, your home for your journey to better FPV fun, flights, and racing stuff. Alright, today I'm excited to be installing my SharkByte digital FPV system into my Kobara Micro FPV 4-inch drone build. I'll be using the SharkByte TX5S.1 video transmitter, which comes with this mount adapter, which we won't actually need on the Kobara frame because it's got a whole lot of different mounting options for us, to include whoop type board mounting patterns for both front and back stacks. I'll be using the Foxeer Digisight digital and analog FPV camera, and we'll be attaching those to the Flywoo Goku GN745 F7 all-in-one flight controller. I'll be installing the SharkByte video receiver system onto my Skyzone 030 FPV goggles. Alright, let's do this. Alright, we've got our SharkByte TX5S.1 video transmitter. And the first thing we're going to do is tin these 4 pads right here that are ground, power, the RX pad, the TX pad. Then we're going to tin the end of these wires that came with it and attach the wires to the pads. Like that. Good stuff. Alright, now we're ready to mount the SharkByte TX5S.1 to the Kobara frame. Alright, even though this VTX board is 25.5 by 25.5, a whoop style type board, I want to mount it with the camera connector here facing the front of the quad. So because we've got the Kobara frame and it's got these various mounting patterns in it, I'm able to do that without a mount adapter. So I'm going to try and mount this board like this in the Kobara frame, and then I'll run these wires underneath the board and solder them over here to these pads. So I've got to run some screws up through the mounting holes, put some nuts on the screws to keep them in place, and then I might add some spacers and stick this board on top of that. Alright, I got the screws through the mounting holes, and I put some nuts to secure the screws to the base plate on the screws. Now I'm going to take these are just some flight control gummies that I've got left over from another build. Just going to slide each one of these on the screw to give the VTX some space between the bottom of the base plate and the VTX so that it's got some airflow. So I'm just going to slide these on, and then we take this just like that, and it fits perfectly. Good stuff. I'll just put some nuts on top of here. And I want to run this wire underneath if I can, because we've got to connect it to these solder pads over here. So let's see if I can run this through the bottom. There we go. That's how I want it to come out. I'll just snip these wires off, tin the end of the wires, and connect them to the solder pads. Alright, I've got the VTX installed. Previously I stated that I wanted this connector for the camera facing the front, and that was incorrect. I actually turned this board around 180 degrees so that this connector is back here per the user's manual diagram. And you'll notice here the VTX antenna is towards the front of the quadcopter, and it runs across the VTX board with a zip tie holding it down so that it doesn't pop off the UFL connector, because the VTX has got 2 holes that you can run a zip tie through. So if you look real close, There's a hole there and a hole there, and I just ran a little wire through those holes, at which point I'm going to run my VTX antenna underneath that wire and connect it to the UFL connector here. And the camera connector will run like this with the camera up front. So I've just rotated the VTX 180 degrees from what it was before, and I've still got the wires running underneath it over here to the Flywoo Goku GN745 F7 all-in-one flight controller and connected up to the solder pads over here on the side. I think it turned out pretty good. Another thing you'll notice on the user's manual for the Shark Byte TX5S.1 is this is a short-range video transmitter capable of delivering up to 200 milliwatts at the 5.8 gigahertz band. And you want to use what they're calling a large capacitor, 220 microfarads. It's required to be mounted in parallel with a power input connector to avoid voltage spikes and subsequent damage to the VTX. I normally do that with all of my builds anyway, so I wanted to point out that I do have a 25 volt, 470 microfarad capacitor attached to the leads of my XT30 connector, and I shrink wrapped that along with my power leads to the XT30 connector. So we've got that covered here. All right, now I've just connected the digital camera's cable, the MIPI or MIPI cable, to the VTX. And then the only thing I have left to do is attach the VTX antenna to the VTX and strap it down with a wire running through these two holes on the VTX. Then we'll button her up, and that should be it. All right, we've got our Kobara all buttoned up with the SharkByte VTX, the Foxeer Digisight camera, the Luminaire Axi VTX antenna, and now we're ready to go with the SharkByte video receiver. Let's get that set up. Looking good. All right, now we're on to the video receiver, and this is everything that comes in the box. Of course, you've got the video receiver itself. You've got a FatShark fan shroud that you can use to replace the original fan shroud on your FatShark goggles. I'm going to check to see if this actually works on my Skyzone 030s here in a second. You've got the VTX control, you've got the HDMI connector, and a couple different ways to power your video receiver module. And then you've got this cable that attaches to the VTX and underneath here on the video receiver to do firmware upgrades. So the first thing I want to do is, instead of trying to use double-sided tape on the back of this on the front of my goggles, I'm going to see if this actually works on my Skyzone 030 goggles by taking my Batman fan shroud off with these 4 screws and then attaching this in its place, which will allow the video receiver module to attach to this. So let's give that a shot. Take these 4 screws out. Of course, I don't want to lose my Batman fan shroud. Keep that. That just comes off just like that. Now we'll get this and see if this actually works on our Skyzones. That right on here. It appears to fit nice. Well, I don't see why there would be any issue here. All the screws line up nicely. Fits good. All right, let's check this out. Now these slide right in here, like that. And then we've got this bolt and nut that slide in through the side. Looks like it's an M3 hex head. So we slide this through here. There it goes. That fits perfect on the Skyzones. Now, since normally most pilots, when they're flying, have their head tilted down a little bit, you want to raise this up as much as you can because these are patch antennas, so that when you're tilting your head down a little bit, it's actually going straight out towards you. But this is really nice that, oh, look at this. This is really nice that the replacement fan shroud for the FatSharks fits the Skyzone 030 goggles. All right, that's good. Now we got to figure out how to power this thing up and configure the settings for both the module and the VTX and camera. Before we power anything up, though, I want to make sure and attach antennas to the modules. I'm going to take off these protectors. My understanding, since these are patch antennas, for the best reception, it's a good idea to add omnis to each one of these. So I happen to have 2 omni antennas. One of them's a right angle, so I had to put an adapter on it to make it come down straight. But we'll go ahead and attach that over here. That'll work. And then I've got the same sort of Menace RC antenna over here. Cover this up over here on my rapid fire. Alright, so since we've got two different ways to power the goggles, this is the one long cable that you can connect a 3 to 4S battery to, and also your goggles and then your VRX with these two barrel connectors. I'm not going to do that just for testing purposes. I'm going to use the single barrel connector to the balance lead, and I'm going to plug that into my RDQ 3000 milliamp hour 2S LiPo. So the balance lead goes here, and then this end goes to the VRX, and this end goes to the goggles. Like that. And then this just gets plugged in here. Put the SD card in, and I'm using a SanDisk SD card. It goes in here like this. I've got to plug the HDMI cable in, so that goes in here. And then this goes into your HDMI in on your goggles, like that. And then I'm going to turn the goggles on. Alright, now that we have everything connected, let's go ahead and set up our SharkByte VTX on-screen display, or OSD. To do that, with our quad connected to Betaflight, we first need to go to the Ports tab and toggle on the Configuration MSP for the UART the VTX is connected to. In my case, with the Flywoo Goku GN745F7, I've got it connected to UART 5. So we toggle this on and make sure that it's set to 115/200. Then click on Save and Reboot down over here in the right-hand corner. Next, we go to our Configuration tab and scroll down and make sure that OSD is toggled on. Remember to click Save and Reboot. Then we go to our OSD tab and select any of these available OSD values listed in the user's manual and place them on our OSD screen where we want them to be displayed, such as your battery voltage, and I will stick mine down here in the lower right hand corner. I've got 3 OSD profiles set up, so that's why I've got 3 columns selected. I've got craft name up here, GPS satellites over here, along with the home direction, and my LQ value. We'll get to that here in just a minute. I've got my timer 2, or my flying minutes, down here, and my GPS lat long, as well as my VTX channel and power. Now if we want RSSI, or LQ in the case of Crossfire, as one of our values to be displayed, then we need to make sure we have RSSI toggled on here. This is true even if you want to display LQ on your OSD. Select RSSI and not LQ. That's just the way this works. We'll need to map RSSI to one of our channels on both our transmitter and Betaflight to make it happen. I'll demonstrate this for link quality with Crossfire. Remember to click Save. In our transmitter, with our quad powered on, we go to our Systems menu and select Crossfire Configure. And then Crossfire Nano RX is the receiver I'm using. Select that, and it'll fill everything in. And then we put the value LQ on our desired channel. So we scroll down here to our available channels, and I normally put mine on channel 12. The DST channel is what I'm talking about. So down here on channel 12, you'll see I've got the value of LQ for Crossfire. Then we exit out. Then with our quadcopter connected back into Betaflight, we go to our Receivers tab. And over here under RSSI channel, we select the aux channel, which corresponds with the DST channel we just set up in our transmitter. Since we use DST channel 12, that would be aux channel 8 in my case. Then remember to click Save down here in the lower right. And that completes our OSD setup for SharkByte. Okay, for the purpose of this video, so you can see what I would normally see in my goggles, I've disconnected the video receiver module, or the VRX, from my goggles and connected it to the small screen that's got a 1280 by 800 resolution display. And we'll use this to navigate through some of the VRX menus, and also to look at both our VTX and camera settings by using our transmitter sticks. First, let's go through some of the receiver module or VRX menus. We navigate through the menus using this 3-button scroll wheel. Scroll left, it goes left. Scroll right, it goes right. Or you can push straight down on it for the middle button. This VRX module has 2 modes. Video mode, which is the default normal operation where it displays live video, and setup mode, which takes you through the setup menus. To switch between the 2 modes, scroll the wheel left and hold it there for a few seconds. That brings you into this setup mode. Once you're in the setup mode, we can scroll left and right to move between the various options, like this. I'll go to frame rate, and to choose one of the options, when the scroll wheel's in its middle position, we just press down. And that brings up the sub menu. And then you can navigate between each of these the same way we did on the main menu. To exit out, I press and hold left. And then we're back to the main menu. Down here you can change your aspect ratio from 16:9 to 4:3. To exit out of the setup mode, we press and hold the jog wheel to the left. And now we're back to the live video mode. Alright, now that we're back in the video mode, to change VTX settings using your transmitter, you squeeze your sticks down into the middle. And we've entered the VTX settings here. From here you can change your VTX parameters and PID settings. You use your right stick to navigate left, right, up, and down. And your left stick, when it's at its halfway position, push it all the way to the right as your enter or select key. And when I do that, you'll see that we enter the VTX settings mode. Here you can change the channel, power, and the low power mode of your VTX. I've got my power set up at 200, but this low power mode, you can toggle between on and off. Now when low power mode is on, if your quadcopter is not armed, the VTX is automatically going to be transmitting at its 25 milliwatt power output. When the quadcopter is armed, it'll then jump up to the output power that you've set for your VTX. So with LP or low power mode on, with the quadcopter disarmed, it'll be transmitting in the 25 milliwatt power output. And then when you arm it, it'll jump up to the power output that you have set. If this LP or low power mode is set to off, then whether it's disarmed or armed, the VTX will be transmitting at the power output which you have selected for your VTX. And to get out of your VTX PID configuration menu, you can scroll down here to save and exit. And now we're back in the video mode. Alright, to change our camera settings with our transmitter, we move our left stick while it's in its halfway position to the right. And now we're in our camera setup menu. We can change any of these values here if we'd like. I left mine at their default values. Now to change the sharpness of your image, which I did from its default value of 130 down to about 80, and then to swap between 50 and 60 FPS, we select exit and then cancel. So we scroll down here and we navigate the same way we did using our sticks previously. We select exit and then cancel, and then within 4 to 5 seconds we need to press and hold our right stick up. So we're going to select exit, cancel, and then press and hold our right stick up. And then we get a different display here. Here we can change any of these values the same way we did on the previous menus. We can change our camera FPS from 50 to 60, our scene, our screen size, or our aspect ratio, as well as our FPS. I'm going to exit out. And then to get back to our video mode, we press and hold the left stick to the left. And now we're back in our live video mode. And we're good to go. All right, now let's take our SharkByte digital FPV system out for a short flight. Please keep in mind, the quality of the flight video you see on YouTube is not representative of the quality of the image you see in your goggles. What you actually see in your goggles is more like what you're watching on the small screen here we're just looking at. me, I find the SharkByte digital FPV system to be great for a few reasons. One, it's got better image quality in my FPV goggles than my current analog system, which is fairly top of the line with our Skyzone 030 OLED screen and the rapid fire receiver module. In addition to that, I was pleasantly surprised to find out that the digital FPV feed with the SharkByte system actually had less breakup, less interference than my high quality analog FPV feed. And on top of that, with the SharkByte digital BTX TX5S.1 all-in-one board, it's lightweight and fits in any of my micros. For those reasons, for me, I found the SharkByte digital FPV system is something that I'll want to continue to fly. I hope you found this video useful, and any comments or questions you have, feel free to leave them down in the comment section below. Thanks for your time, and I'll see you next video. Clear skies, friend.